SecuPi and Starburst. Welcome to the SecuPi Starburst joint webinar titled Securing and Identifying AI Access to Sensitive Data. With me is Ben Lambert and myself, Alon Rosenthal. Ben, if you can introduce yourself.
Yes, thank you, Alon. Hello, everyone. Ben Lambert, Partner Solution Architect and Manager here at Starburst, and I work with all of our technology alliances, including SecuPi, and excited to talk to you more today about securing and de-identifying AI access to sensitive data.
Thank you, Ben. And myself, Alon Rosenthal. I'm the SecuPi CEO and co-founder. Also been doing data science, data security, data privacy for the last 15 years. I invented dynamic masking back 15 years ago, before GDPR era even. So happy to be with you and share how to protect AI access to sensitive data. Ben, the floor is yours.
Excellent, thank you. Yeah, so we can go ahead and get started. Just to give you a quick rundown, we'll give the group here a brief overview of Starburst and a little bit of background on who we are, and then I'll hand it over to Alon to give you a little bit of background on SecuPi and who they are. Then we'll dig deeper into some of the challenges that are facing current AI ML workloads around securing access to that data. And then we'll finish things off with a demo as well as some questions and answers. So we do want to keep this conversational as we go throughout. So feel free, if you have questions, to post them there in the chat. Okay, so we can proceed to the Starburst overview. Okay, you can go ahead and click through a few times here to build it out. That's perfect. Thank you. I'm sure, as most of us have been in the data scene or the data environment for, quite a while now. I've been in it over 20 years. You've probably seen something like this start to evolve or happen in the various data ecosystems that you've worked in, right? Back in the day, things were pretty straightforward. You had this single monolithic data warehouse. That's where all your data was. And you would just connect your tools of choice, whether it's a BI tool or your data science tools, directly to that source. But as times have changed, as data ecosystems have become more complex, getting everything into that single source of truth really becomes not only a challenge, but a burden to a lot of ecosystems out there, right? So you've got not only your relational data, but you got streaming data, you got semi and unstructured data, maybe you've got a data lake, streaming ingest, things on-prem, in the cloud. And really what that does is it makes it a lot harder for folks to get access to the data they need, essentially creating these silos, which I'm sure you've all heard of before. And silos really not only are painful to deal with because, again, you have to set up all these different connections and make sure everything's secure and make sure that everyone knows where the data is at, but it also costs more time and money, right? So you have to put into place these pipelines that move the data from certain locations, oftentimes taking multiple copies of the data, all to really try to get it back into that single source of truth, which really slows down the progress of your company and really delays the time to insights. So if you can go on to the next slide, please. So here at Starburst, we're really, trying to shake up that paradigm and encourage folks to start looking for a better way to orchestrate or architect their environment. So Starburst is a MPP query engine. We're an analytics engine. We sit in between whatever application you're using to consume your data. So it could be your favorite BI tool like Tableau or Power BI. It could be your favorite transformation tool like dbt, or maybe you're using some kind of client to train and build your models and run your workflows, your AI ML workflows. As long as it supports JDBC or ODBC, you can connect into Starburst. We support ANSI SQL standards, so you're not having to learn any special one-off flavor of SQL or any unique coding language using standard SQL. When you issue your queries to Starburst, we then can reach out to all of your underlying data sources for you, whether they're on-prem, in the cloud, your data lake, cloud data warehouses, streaming systems, you name it. We will then pull the data back into memory, joining it in memory for you, and then returning it to your calling application. So this really helps break down a lot of those data silos that you most likely are running into in today's world. Through a single query in Starburst, you can query data from multiple sources. So I can join data from my data lake on-prem with data from my cloud data warehouse or a streaming system, all through a single query. And again, Starburst is doing all the processing in memory for you, so it's super fast. You don't have to wait for, again, those upstream processes to happen, like running pipelines to push all the data or copy it all into a single location first. Instead, you can leave the data where it's at and allow Starburst to do all the heavy lifting for you. Okay, next slide. And to extend this even further, what we're seeing, these days really come about, the more popular ideas now is really getting more value out of your data lake. So, I wouldn't be saying this 10 years ago, because data lakes were turning into data swamps. People were having trouble with the maintenance overhead and the costs associated with it and all the different kind of unique languages that they needed to learn to access that data. But with the emergence of query engines like Trino, which is the open source query engine that Starburst is built on top of, we're actually able to see warehouse-like performance coming out of the data lake. And then with modern table formats like Iceberg, you get those kind of CRUD support or ACID support that you need, so you can get warehouse-like features as well directly on your data lake. So by combining things like those open table formats with powerful query engines like Starburst, you can actually start to leverage your modern data lake, you can leverage your data lake for your modern analytics workloads. So you can put all your data in there, you can have it stored across multiple formats, you can have it stored across multiple clouds or even on-prem. And through Starburst, powered by Trino, you can use your same anti-SQL queries, your same tools of choice today to access that data. And we've been, pushing this messaging for a while now, and we've seen great results across the board. We have some of the largest customers in the world who are now starting to rely more heavily on their data lake without having to sacrifice performance. So they're getting their insights just as fast, if not faster than before. Part of that is because, again, they don't have to invest all that upstream effort into consolidating the data, building those complex pipelines, or copying the data into multiple locations. But then with the performance of Trino, we can do push down, we can do additional performance tuning to ensure that whenever you're retrieving data from your data lake, you're doing so as fast as possible. And then since we're using the data lake as the storage layer, and since we're using these open table formats, you can ensure that your overall cost of ownership is going to be a lot lower. So, just imagine putting all of your historical data and your current data in the data lake and still getting the performance you need for your analytical or machine learning workloads, all at a fraction of the cost. Okay, next. And then over the next couple slides here, I'm just going to give you a brief intro to Starburst's perspective on AI. Of course, this is the hot topic these days, and we're still formulating our perspective on this. But this is kind of the start of where we're at today, and we'll continue to evolve this over the next months and years. Next slide, please. Oh, looks like maybe those slides got skipped. Yep, my apologies. For some reason, they are not in that deck. Let me pull up mine right quick.
Yeah, let me share it for you. The one?
No, if you don't mind, I can share my screen right quick. I've got the slides up on my side, and then I can hand it back over to you.
Sure.
All right, thank you. Actually, doesn't look like I can share my screen. Are you able to give me sharing permissions at all?
Is it working now?
Yep, it's working now. Thank you. Alrighty, can everyone see my model creation using Starburst slide?
Sure.
Yep, excellent. Thank you. So I'm guessing if you all have hopped on this webinar, you've have some familiarity with AI ML workloads and model creation. So hopefully some of the terms and whatnot that are going to be shown here on the slide will resonate. But at the top here we have the basic kind of steps, if you will, and again, this is a very simple version of it. But the steps involved in model creation and then eventually the model serving. So you're looking for, exploring data, trying to extract that out of whatever source systems are available to put it into a location where you can actually start doing your analysis and developing the model itself. Of course, with that's going to come some data prep, so you need to do some scrubbing, some data quality checks to make sure that the data is where you need it before you actually start building your model, or I'm sorry, before you actually start training your model and then validating it. So where Starburst can really help throughout this whole life cycle is because we can connect to any sources anywhere, because we can combine data from multiple sources through a single query, and because we leverage an open standard like ANSI SQL, we can essentially be that data access layer anywhere in your model flow. So all the way from extraction to the actual end model training and validation, whenever you need to reach out and get data, whether you're pulling in that data initially, or you need to run some transformations to actually scrub the data or prep it appropriately, or then when you're using your AI ML tools to start building and training the models, most of those tools support JDBC ODBC connectivity, so you can use that to connect to Starburst. And again, Starburst will take those queries, that information, it will reach out to the underlying data sources for you without having to move the data around. So we will push down what optimizations we can into the underlying data source to maximize data retrieval. We then pull that back into memory, combine the data into a single result set for you, and then push it back to the calling application. Or in the example of if you're doing data prep, you could essentially within that data lake, within that modern data lake, you can access the data in table format. You choose your format. You can then create new copies of that table if you need, the scrub versions, if you will, of those tables, and then push those back into the same location. And then just another quick example here, putting in some more like real world information, I guess you could say. This is a simple example for a manufacturing company who's using AI and Starburst data products to try to improve their recommendation engines. So for those who don't have much background on data products, that is a feature in a modern data mesh architecture. Essentially, it's a curated data asset that has some additional context around it. So it's not just a view, it's not just a materialized view in your database. It is a series of views, most likely a full schema of information, but it gives you space to actually provide additional context. So rather than just have an obscure view name with some data in it, you want to be able to provide the users who are going to consume that data with the context they need to understand how best to use it, right? So you might let them know that within this particular data set, I've got factory information, logistics information, information about parts and suppliers, and then some additional, deeper level business context around that data and how it should be used. That helps speed up the overall AI ML workflow because when your data scientists start to get in and actually want to start exploring the data and building and training their models, they don't have to sit there and kind of search endlessly through all these cryptic table names and whatnot to try to find the data sets that they need. And furthermore, even have to combine that data themselves in a way that they think is needed. Instead, you can have some subject matter experts who know how to combine those data sets appropriately, create these data products so that when the data scientist comes in and actually needs to start training their models, they can leverage that data product, which again could be a single query or a single view rather, that combines data from your data lake, from cloud data warehouse, from a streaming system, from any system that you have in your data environment, all through a single query. And again, they don't have to write that SQL every time. It's already written for them. It's baked into those data sets. So it helps them really focus on training the model and validating the model versus having to spend too much time exploring and trying to combine that data upstream. So I'm going to pause there for a second. Are there any questions from the group before I hand it back over? Okay. I will stop sharing and hand it back over to you, Alon.
Great, thank you. Thank you. Okay, good. So we're talking about the need for data, right? And how do we balance the usability of the data and the liability that comes with it? We in SecuPi are doing that for many of the Global 2000 organizations from all industries, where we see also AI requires that because AI, of course, use cases can cross the entire organization data. It can start from a customer experience and supply chain. It goes to fraud detection in many of the financial customers that we have. It goes also to Customer 360, putting data around customers, around employee data, supplier, and other type of data sets. All of those data sets have different type of restrictive usage to it. It may have the requirement to apply right to be forgotten. It might require certain levels of consent to be processed. And it simply can be, private information of our employees that shouldn't be able to be abused by their peers. So we need a very strong identification platform that will cover all AI usages. So how to do that? SecuPi, a platform, has 3 different layers to it. The first layer that SecuPi includes is a data monitoring and classification tool. SecuPi out of the box allows you to classify, tag, and monitor access to sensitive data that is consumed through Starburst. So all access to sensitive data through its entire sources through Starburst is real-time monitored, tagged, classified, while assigning to that a risk based on the sensitivity of the data that is now accessed by end users, or as well as by the different AI engines. On top of the monitoring of access to sensitive data, we have the access control. Access control is providing what is called least privilege requirement. Least privilege means that every access to sensitive data needs to adhere to a least privilege concept. This is something that has been coined by the Zero Trust. In order to achieve Zero Trust perspective, we need to ensure that every access to sensitive data is done on a need-to-know basis. Need-to-know basis means least privilege. To do that, the SecuPi platform has an ability to integrate with identity sources such as Azure AD and LDAP, data catalogs such as Elation and Colibra, as well as location information, single sign-on authorization tools, in order to poll attributes and to restrict access based on those attributes on a row, column, and cell level. But this is not enough. We need also to identify the data at source. For example, to adhere, of course, PCI regulation, to adhere the GDPR sovereignty requirements of lifting data to different cloud providers. We need the ability to identify the data through encryption, tokenization, deletion, masking of the data before it is being lifted or before it is being consumed by the AI training processes. SecuPi comes out of the box with different identification functions. The straightforward from them include tokenization, formal preserving encryption, where you might require to encrypt certain elements even of the email, keeping maybe the domain, but encrypting the first the name, but also providing partial encryption to, for example, social security number. It also has the ability to manage the keys, the encryption keys, both the key encryption key and the data encryption key, either on each one of the AWS, Azure, and GCP KMSs, or in an on-prem HSM as well. Also for files, we provide AES encryption and AED encryption, and this allows us to apply the encryption by keeping the format, but format encryption is not enough. Today, organizations require also type-safe encryption. What's the difference between type-safe encryption and formal preserving encryption? Because formal preserving encryption might create some strange results which are not consistent with the type of the column. For example, take a date. If you take a date and just do formal preserving encryption, you get also a different format, the same format, but a different type, right? Because 23rd of February, 87, when I just do formal preserving encryption, I can get into strange dates, like 38 of the 13, 0066. This is from the area of the Roman Empire. Of course, not compliant with the date type. SecuPi keeps also type preserving encryption, ensuring that when we're encrypting dates, we are keeping that on the same type. When encrypting an integer or a byte, it is still be encrypted into a byte format. So in addition to the formal preserving encryption, which we provide, which is a NIST standard, we also provide a type-safe encryption on top of that. In addition, we also provide different type of blurring. For example, for cases where you have low entropy data, take, for example, blood type, or gender. Right? We can encrypt that into multiple values, so we can keep the data itself, as well as applying, and this is also for HIPAA compliant. We are able to apply bucketing and rounding of dates and ages. We're also able to apply dynamic masking of the data, replacing zeroing, and also obfuscating the data. So we obfuscate a name to a different name. This is very helpful for training models, that you want also the result to be perceived as the actual names or emails. So the obfuscation function also is very helpful. Of course, we also provide masking and form preserving masking. The difference between masking and encryption is that masking is irreversible, like obfuscation or dynamic masking. Encryption tokenization is reversible, which means that we can decide from every data set which columns we want to have the AI results be completely anonymized and feed the model with masked data, or it might require to be reversible, for example, for a patient ID or a client IDs, which we want also to revert back to the original client. There we might require to use encryption and tokenization, types of encryption and form preserving encryption for the reversibility of that. The enforcement of SecuPi, the identification function, is very important both for the training and for the actual usage of the models. And this is done on top of Starburst by simply putting a jar file on the Starburst server. So from an implementation perspective, in order to identify the data that is lifted, that is used by Starburst, the only thing we need to do is simply to install a SecuPi management server. By the way, and SecuPi is something that you deploy in any one of the clouds. We are providing our software as an EKS, AKS, JKE, and others, or an on-prem Kubernetes cluster, as we serve also the US Department of Defense. And for that, we are able to deploy SecuPi in your VPC environment or in your premise. And from the management server, we simply put a jar file, and we call it the Starburst agent. We put a jar file on the Starburst Java worker node. And what this jar file is doing, it is applying those identification functions on the data sets that is being lifted and consumed by the AI. This is used in order to address the different challenges of AI, abusive access, addressing data sovereignty laws. And we're hearing every month new sovereignty laws being legislated. For example, the recent one in Indonesia, in Malaysia, in the Philippines for financial information, Singapore, but also the DORA requirements in Europe that is following the steps of the GDPR and Schrems 2. Also keeping the data storage, identifying the data there, and protecting the AI models both from insider threat as well as applying cloud data security at the source. This is a good time to break to a quick demo to show you how SecuPi jar file that is configured on the Starburst cluster will be encrypting a column. And I will stop the sharing. And Jonathan, if you can show a quick demonstration of that.
Good morning, good afternoon, ladies and gentlemen. I'm assuming you can see the screen. So let's carry on. So as Alan spoke through this, if you remember the pyramid, there was a structure there. Starting at the bottom, it's the idea of understanding what's happening. So this is a very simple setup. We have a set of data. I'm pulling data in from one table inside a Postgres setup, and it's displayed here. If I run a query, we get some data back. Very interesting data, lots of potentially useful information if you want to talk to Lenita or Carol. But as we start looking at that, it's a case of we, as in SecuPi, can start analyzing and looking at this data and seeing what's coming in. So if we look at this, we've got the request is by SecuPi admin. So that was the user that I used to build the Starburst. The IP address that it's being run from, and the role that SecuPi admin has. You can look at the query that's been run. You can see where it's being run. So I'm running it on an original name, JP Starburst. So I've built this, we've built this in the cloud. And then you can start looking at some more detail of actually what data was returned to the user.
Yeah. Now, this is very important because this provides you the observability of the consumption of the AI results. A SecuPi can be deployed on the different AI platforms in order to monitor the accessibility of sensitive data, where every request is also tagged and classified. You can see that the different colors that we are assigning to the request means what actually data was accessed by this request. We are also calculating a risk score. The risk score of the request is calculating which columns have been accessed, multiplied by the result set size. If we're talking about 10 patient records for healthcare, then the risk score is X. But if we're talking about 10 million patient records, then the risk score is, of course, much, much higher. So not only that we want to tag the request based on the different data that it is being consuming, but also give it a risk score based on the sensitivity of the results that it is being consumed or processed.
So that talks about the DAM side of things. So the idea here is now I don't actually want my user or users to see, well, I've chosen email as the easiest one. So I've already built in here an access in resource access a rule. So this is a very specific rule. We could be very generic and have it for the whole table. I'm just doing it for a specific rule for email. We're coming in, and by default, any user at the moment sees it in clear. If I change this to masked, then we come back here and run this rule, or run this query again. You can see now that the email has been masked, but it's been masked. If I can drag this column across, only the username has been masked. We have left the domain clear. You might want this for your downstream marketing structures to understand where your leads have come from. But it's the idea of coming back to something that Alan's already talked about, format preserving encryption. We've chosen just to mask the name, leaving the domain empty. So you can use this to potentially build just the first 4 digits of the credit card, or other elements that allow you to utilize that data without necessarily understanding what that data is.
Yeah.
Now, if we go back to the dashboard, you'll see here that a rewrite has occurred. So again, the dashboard tells you what data's happened and what data is returned to the consumer, but also what has been happened to that data. So you can see here, the column email has been rewritten with the format preserving masking. So FPM. If you want to look at it from encryption point of view, we could just change this again for encryption. And again, I'll run the query. And now we should see this change. So now you get to see an encryption rather than a masking. So coming back to Alan's point, depends upon your business needs, depends on whether you want to mask or encrypt. So if we come back up to the dashboard. You'll see this time we have used a different method, mail FPE, format preserving encryption, rather than format preserving masking. So it's giving you the ability to choose various things. I'm only doing this on one user because that's what I've built so far. We have the ability to mask dependent upon user, dependent upon the role of that user. So therefore, you can get very, very granular structure based on people's need to know about the data.
So the usability of that is that Starburst is used as the way to the data, right? The way to open up the data of different domains, whether this is on-prem or this is a consumption into AI from an Iceberg or Parquet file, right? On-prem or cloud, SecuPi layer on top of the Starburst by simply putting the SecuPi jar file on the Starburst working nodes, we are able to provide all of those different identification functions of both data at rest as well as data in use. And for every AI purpose that you are building the model to, we can decide should those and those elements should be encrypted, masked, restricted, filtered, or even deleted. One common use case that we've seen in the past is even consolidating SecuPi through a list of client IDs that belong to a certain type and filter them out from being consumed by the AI. This is something that SecuPi can orchestrate, can pull the list of client IDs or identify the client ID type and apply those filtering controls on the data that is being lifted to AI.
So just to carry this forward, to create a rule, you can import them through your catalog and build it that way, or you can click here. Coming back to Alan's conversation about the risk score, this is where you put an idea of the sensitivity of the data. The data at rest is clear because behind Starburst is a clear database running on Postgres. The format, we've built a set of generic ones to start with, but this allows you to come up with a structure. And if I call this name, save that. And then if we come back into Starburst, check the name and then run it, the name has now become encrypted. So yes, if you want to do each one individually, you might say that's a lot of work because of the size of my database. We can take, as Alan's already said, we can take feeds from other catalog providers or various other metadata sources to allow us to build and automate this structure. Any questions?
So I see one question, which is what are the other platform supports that you can apply the data identification on? So let me share the screen for a moment. So if you go to the SecuPi website, you can see in SecuPi.com coverage, the entire platform support that SecuPi provides, both from business applications, cloud platforms, the AWS, Azure, GCP platforms, data formats such as Parquet, Avo, Iceberg, and others, as well as on-prem sources, reporting tools, and ETL tools. So you can go to the SecuPi.com/coverage to see the entire platform support of the data identification function that we come and we have presented to you here.
I also have I've built the same demo, but using dbeaver as the access mechanism rather than the Starburst web page. So I'm coming in through using Trino driver through dbeaver to access the data, and again encrypting it in the same way. So let me just show you that quickly. It's using the
You
same.
need to put the presenter. Please select the presenter.
Sorry, is that better?
Yeah, thank you.
Sorry.
By the way, this is a use case also for privileged users, right? Usually we are fixated on protecting data from analysts and data scientists, and we might overlook the need to protect also privileged users, DevOps, developers, DBAs that have a highlighted privilege to all the different data sets that we have. So in this demo, Jonathan is just showing that also through different RegDB tools, such as dbeaver, we're able to apply the same level of controls, both the protection of data at rest and in use, as well as the monitoring also on even the RegDB tools used by privileged users.
So you can see here the fact that this is actually deterministic encryption, format preserving encryption. So because I'm using the same structure, it carries on between the tools. If you don't want format preserving, if you don't want deterministic, we can change that. But it's giving you that level of flexibility dependent upon what you want to do. So if I come into here and change the default access back to masking, we run it again inside here, you'll see that it's masked. Oh, sorry. Come back down to my query that I've been running it against. So you get to see email and name masked. If I come to here and run the same query, you see the same structure. So it gives you the commonality across the tools because I'm accessing the same data set. So it's all coming through Starburst from Postgres, and I'm accessing Starburst from here. So if we open this up, you can see I'm using that as my data source, but it's the idea of having a level of commonality between the tools you use to access the data, be that a DBA or be that an analyst.
Another important reason for that is that the ability to join, right, different data sets. You want to have a common identification function on the different columns across different databases and platforms and environments. And for that, the ability to scale out and to provide the same level of identification across even on-premise data platforms as well as cloud is important to gain the benefit of the analytics. As you can join things together, you can group them, and you can get the most of the data itself. Ben, any last comments before we close the webinar?
No real comments. Just appreciate your time and showing the wonderful things you can do with SecuPi. You know, I think this is especially important with a system like Starburst, where you're accessing multiple systems and you want that consistency across systems. So the format preserving capabilities that SecuPi has, I think, are immensely valuable to those workloads.
Thank you, Ben. So we will now be closing the webinar. If you have any other questions, don't hesitate to reach out both to Ben and to me and to the SecuPi team. Thank you for spending time with us and looking forward for working with each and every one of you. Thank you very much.
Super, thank you.
Thank you all.